So let's start with terminating decimals. All right, so if you have a terminating decimal, the steps that you will use to convert it into its rational form, meaning its form as a fraction, is you're first going to start by just writing all the digits. And you're going to disregard the decimal point. So you're just going to write the digits. So if I take this first example, I have 1854. Again, I didn't put my decimal point in there. Next, you're going to set n equal to the number of digits that came after the decimal point. Okay, so here my n value is, when I look at my original form, I have 3 digits after the decimal point. So my n value is going to be a 3. And what you're then going to do is you're going to divide your number. So you're going to divide a by 10 to the power of n. Okay, so when I divide this by 10 to the, here my n value was 3. I get 1854 divided by 10 cubed is 1,000. And so this is my rational form. Now, when you enter these, you are going to reduce your fraction. So we are going to reduce this. When you work with your quizzes, tests, and your final for the pre-cal prep material, you do not have access to your TI-89s. Right? You'll have access to a basic scientific calculator. Right? Although on your final, there will be no calculators at all. So you need to be able to work with something like this by hand if necessary. Okay, and so what you would do if you had to reduce these by hand is you would just look for some of the simple components that you can find. So division by 2 is an easy one, right? Both numerator and denominator are even numbers. What about division by 3? Do you guys know what the rule is for division by 3? If you add up all the digits of your number, that if that number itself is divisible by 3, then the whole thing is. So if you look at this top here, 1 and 8 is 9, plus 5 is 14, plus 4 is 18. Is 18 divisible by 3? Yeah, so this whole number would be divisible by 3. Okay, the similar rule works for 9. If the total sum of the digits is divisible by 9, then the whole number is as well. So here this sum of these was 18, so would 1854 be divisible by 9? Yeah. Okay, division by 4, you just look at the last 2 digits. If the last 2 digits are divisible by 4, then the whole number is. So like if you looked here, 54, is 54 divisible by 4? No. So that means that that whole number is not. Division by 5, the number has to end in what? A 5 or a 0. And the only other one that you might see, and it'll come with the next rule, is division by 11. And one of the easiest ways to decide whether something is divisible by 11 is look at the alternate, or look at every other digit. If the sum of every other digits are the same, then the whole thing's divisible by 11. Meaning, if you looked at this, 1 and 5 gives us 6, 8 and 4 gives us 12. Are those exactly the same? No. If they were, then the whole number would be divisible by 11. All right, so in this case, the only rule that works is 2. So if we divided both sides by, or the top and bottom by 2, we get 2 goes into 18, 9 into 5, 2 with 1 remaining into 14, 7. So we get 927, and 2 goes into 1,500 times. And you could continue to look and see, are there any other division that occurs here? If you use your calculator, you can confirm this. I'll go ahead and take 1854 divided by 1,000. My TI-89 will reduce this down as far as it can go, giving me the same number that I just got. And then you can always double check your answers. If I took this number, 927, and divide by 500, I'll put a decimal here so my answer displays as a decimal. When I hit enter, I should get 1.854, and I see that I do. It confirms that that is the correct value. All right. The second type of problem that you're going to be looking at is one where you have these repeating but non-terminating decimals. Okay, so if you're looking at how to solve the problems with the repeating but non-terminating decimals, you're going to set it up in the following way. If the first thing that I would do is create an equation where you set x equal to the original number. Okay, so the first thing here is I would say x is equal to 8.14 repeating. I'll always represent the repeating digits with this bar over the top. Even if it was given in the ellipses, the dot, dot, dots, I'll set it as the bar. You're then going to set n equal to the number of digits that repeat. So in this case, I have n is equal to how many digits repeat in this problem? 2. Okay, then the next step is to create a second equation. And you're going to do that by multiplying both sides of this equation from step A. By 10 to the power of n. Okay, so here my 10 to the power of n, 10 squared is 100. So if I multiply both sides of this equation by 100, I get the new equation 100x. And here, multiplying by 100 moves my decimal 2 places to the right, so I get 814. And because the 14 continues repeating, I get 141414 and so on. And notice I wrote that equation above my original equation. My next step is to subtract my original equation, which is equation A, from the equation I just created in step C. So if I subtract these straight down column, I get 100x minus 1x gives me 99x. Okay, so I get 99x here on the left side. Now, if I've done this right, my repeating digits should line up exactly over each other. So when I subtract those will all cancel. And really what I'm left with is 814 minus 8. That's going to leave me with 806. Okay, and then I'm going to solve my equation for x. And that's going to be your rational form. Okay, so here when I divide by 99, I get x is equal to. Now, going back to our same rules here. Okay, notice this left side in this step right here, this is always going to be 10 to some power minus 1. So you're always going to be either left with 9x, 99x, 999x, 9,999x. So it's always going to be 9s repeating. Okay, so the values that you can, in this particular case, you can check for division by 9. So if I add the digits 8 and 6 together, I get 14 is 14 divisible by 9. No. Divisible by 3. No. Okay, 99 is also has a factor of 11. So when I look at these alternate digits, do they add up to the same thing? So is 8 plus 6 equal to 0? No. So I don't have any of those rules. There's no even numbers on both the numerator and denominator. So this is my simplified form. Okay, and I can go in, and once again, I can confirm my answer. If I type in 806 over 99 on the T99 and hit enter, it will reduce it for me, showing that this is the reduced form. And if I wanted to verify that this is the 8.14 with those 2 digits repeating, if I do the calculation, I see 8.141414. It shows me that that is correct. Okay. We look at this first problem here. I see it's a terminating decimal. Okay, so that tells you I'm following these rules up here. I'm going to write my digits, 7984, divide by 10 to the power of however many digits come after the decimal. There's 2. And so this is my simplified form here, 7984 over 100. And as I work through this, I can look to reduce, like based on my division rules. Okay, I know that my last two digits here, so they're both even numbers, so I know I could reduce or factor out a 2 from both. But because my last two digits are 84, I know that this top number is divisible by 4. Is 100 divisible by 4? Yeah, so I'm going to go ahead and do that one first. 4 goes into 7 once with 3 remaining. 4 goes into 38 9 times with 3 remaining. 4 goes into 36, or 38 9 times with 2 remaining. And 4 goes into 24 6 times. So here's my new numerator. And then 100 divided by 4 is 25. So this is my reduced form. And then I can see 25 only has factors of 5 times 5. There's no ending of 5 or 0 in the numerator. So this is my simplified form, 1996 over 25. Okay, like I said, you are going to have to reduce these fractions. Okay, if you entered 7984 over 100 in this answer field, it's going to mark it wrong. And so make sure you reduce everything down. Okay, in the second example here, you recognize what type of problem you're dealing with. It's a repeating digit. There's 3 digits that repeat. So the first thing I'm going to do is set x equal to my original number, 9.784, with a bar across the 3 digits. Okay, and then I'm going to establish the number of digits. My n value is 3. So I'm going to take 10 to the third, and that's 1,000. I'm going to multiply both sides of this equation by 1,000, and I'm going to write that new value above. So here I get 1,000x. And here when I multiply by 1,000, that decimal point gets moved over 3 spaces. And then the repeating digits of 784 continue. I'm then going to subtract straight down the column of like terms. So on the left side, 1,000 minus 1 leaves me 999. The right side, this repeating digits of 784 will cancel. And I'm left with 9784 minus 9. So that leaves me with 9770. And again, really you're taking 84 minus 9 is 75. Divide both sides by 999. So here is my fraction. I just want to make sure that this is simplified. When I look at my denominator, I'm going to test for divisibility of 9 or 3. And so when I add up my digits here, I have 7 and 7 is 14, plus 5 is 19, plus 9 is 28. Okay, so does that give me division by 3 or 9? No. So I look at my last digits. I have a 5, so I know the top is divisible by 5, but the bottom's not. And so based on those rules, you're probably pretty good to say that this is your simplified form. And if you verified it, 9775 divided by 999, I enter, so there's nothing that reduces here, so I do have my reduced form. And then if I put a decimal here and hit enter, it should give me 9.784 repeating. And I see 784, 784, 784. It confirms that that is my correct answer.